Hi everyone, we are Group 1. My name is Uyuchi. Here is a brief introduction of our team member and their contribution. Next, I will explain the background and end of our project and introduce what laptop we use. Here is our group member. We have 4 members. Zheng Yuxi is team leader. He coordinated our group projects and handled task distribution. Uyuchi conduct back-marking test use CPU-Z and gap back on a laptop with an Intel i5-11320H processor and write ASM code program for back-marking software. Maria was responsible for testing on a high-performance Intel Core Ultra 7155H device. He contributed significant results and for CPU and disk performance. Sahara compared the final report and write important sections, include methodology and compare on comparison and conclusion. Next, let me expand the background and air of our project. System performance is high depending on hardware, but many students don't have hand-on experience in evaluate how CPU respond under stress. So our project air to compare CPU performance across different laptops used from NASM accessibility code and backmarking to like CPU-Z and gap batch. Our objective is benchmark different laptops use CPU-Z, gap batch, and task manager and mini to analyze the difference in performance and understand the hardware impact, and use a polynomial equated in MASM assembly. Y equal A times x cubed plus B times x squared plus C times x plus D in MASM to stress the CPU. Make sure execute the time, use gap and second with various loop code. The tab we have 4 laptops to test. Computer A is Intel Core i5 8GB RAM SSD, and computer B is Intel Core i5 11320H 16GB RAM SSD. Computer C is Intel Core Ultra 7155H 16GB RAM SSD, and computer D is Intel Core i3 4GB RAM HDD. We use 4 to pair CPU-Z and gap batch and task manager and mini to this pair testing. Okay, thank you.
Hello, I'm Maria, student C. So I'll be showing the execution results for each student. Here we have student A, that's his CPU-Z, showing the CPU processor, which is the clock cycle and speed, and also showing the cache. And here showing the memory and motherboard. Here, using the mini tool, that's his results for the sequential test mode. And that's his result for the random test mode. And for the Geekbench, showing his single core score and multi-core score, and system info, CPU info, and memory information. And that's his single core performance, and that's the multi-core performance. And for the task manager, it showed for him for the high load 71% and the medium load 59%, and the low mode is 27%. And we go to student B. So that's her CPU-Z for the processor and cache. That's the memory and motherboard. And that's her Geekbench single core score and multi-core score. and system information, CPU information. And yeah, that's her single core performance and the multi-core performance. And using the mini tool, that's the results for the sequential test mode and the random test mode. And the task manager showing her 45% for the low mode, medium load 58%, and high load 82%. Now we go to student C, which is me. My CPU Z, processor and cache, and the memory and motherboard. Here my Geekbench single score and the multi-core score, system information, CPU information, memory information, and that's my single core performance results and the multi-core performance. And here the mini tool for the sequential test mode and the random test mode. And here my low load 38%, my medium load 50%, my high mode 70%. And we go to student D, her CPU Z, showing the CPU processor and cache, and the memory and motherboard, and her Geekbench showing the single score and the multi-core score. Also the system information, CPU information, memory information. That's her single core performance and her multi-core performance. And her for the mini tool, the sequential test mode results and her random test mode results. And yeah, that's the monitor, the task manager. Her low mode showing 43%, her medium load 56%, and her high mode 87%. And yeah, that's for all.
Hello, Doctor. My name is Zahra Putri, A24CS9006, and I will present my part, the comparison and discussion part of our benchmarking project. With tests for different laptops using various tools and metrics, here I'll explain the result insight we gained from this process. For the CPU performance, first we look at the CPU specification. The student A have a most powerful CPU, the Intel Core i9, but unfortunately Geekbench wasn't performed, so we couldn't measure actual performance. A student B had a mid-range i5 11320H. This one is good for daily tasks. Student C used the modern Intel Ultra 7, ideal for multitasking. Meanwhile, for student D, had an older, so which is okay for basic use but not suitable for heavy workload. For Geekbench performance, student B achieved the highest single core score, which means the great responsive for single threaded apps, and for student C, the highest in multi-core performance, perfect for multitasking and parallel tasks like coding. And student D score were the lowest, which matched her device older specification. Next slide. For this benchmark, in terms of storage speed, student C was the fastest, nearly 7000 MB as read and 4 MB as write speed. Student B also performed very well, especially with write speed close to 4000 MB, and student A drive had decent speed, while student D had the slowest but still usable for general tasks. This show how modern SSD like C greatly improve responsive for largest file operation. Resource usage or task manager, we also monitor RAM and CPU use under different load level. Student C and B handle load well. They stay under control even with multiple application open. And student D laptop reach 85% RAM and 40 CPU usage, meaning it's easily overload. Student A had incomplete data but show 4% CPU use under high load, affected by background activity. For the assembly loop benchmark, we test a polynomial equation in assembly code with increased loop counts from n 15 to 100. Execution time increased linearly, which is accepted. However, the n equals 50, 100, and 1000. Student D's results were identical 21 739,994 ms, which is unusual, even strange. And then n equals 700 had much lower time than 500. These anomalies had been due to measurement limitation in the function or system interaction. We've included the full table of results here for comparison. I think that's all for me. Thank you.
The object is evaluate the CPU and disk performance of a laptop using the four free tools: the CPU-Z, Geekbench, and Task Manager, and Mini-tool. While a MASA assembly program to perform the multiple loops of the polynomial calculation and measure latency, verify the response difference of the CPU under varying workload. Methodology: hardware information collection. The CPU-Z record clock speed, cache specification, and so on. The CPU stress testing, Geekbench single and multi-core benchmarking score, plus test management monitor 3 round level. The disk benchmarking, Mini-tools measure SSD or HDD sequential random read and write speed. Ensemble loop testing, MASA iterates 50 to 1000 times, recording execution times. Key results: the i9 13980HX leading the overall performance. The older i3 lost by the approximately 70 SSD speed SCE 2040 MBS, while HDD speed are approximately 110 MBS. Other high load input and output with time in test manager significantly increase. The high load maintain plus than 80 percentage utilization and good temperature control for mid to high-end CPUs and allow an i3 experience frequency throttling, indicating that thermal and power signal design also determines sustained performance. Loop time and the iteration counts for the four model are approximately in linear. Slope different quantify single computer license. The conclusion. Through the group collaboration, we have the gain insight into how Class B costly counts and cache capacity determine single core and multiple core performance. SSD significantly enhance overall system throughput. The two combination has been validated as effects. CPU-Z provides that specification. Geekbench and MASA loops provide dynamic computation logs, and the Mini-tool evaluate input and output and test manager monitor real-time results, offering a comprehensive perspective for education purpose.